We all have used IP addresses, and this next bit of our discussion might seem a little redundant. But addressing is an important part of services IP provides in the network layer of the Internet. Each endpoint is connected to their network with one immediate link. A link is connected to a physical port, and that port has an interface. We assign IP addresses to interfaces. An IP address in version 4 of IP protocol is 32 bits long. Therefore, there is a possibility of allocating 2 to the power of 32 distinct addresses using it. We depict IP addresses as a combination of 4 8-bit numbers read as decimal numbers in the range of 0 to 255, separated by dots. For example, we will read the depicted IP address as 223.1.1.1. IP addresses are assigned to the interface connecting the endpoint to the network, and that endpoint would be identified uniquely in the network using the assigned IP address. A valid question you might ask at this point is, how are the interfaces actually connected to the links? We might have different types of links. For example, in a very broad sense, wired or wireless. And to have an interface with those links, different protocols will run at the data link layer. We will discuss this in details in the data link layer discussions. For now, we will use interface as an abstraction of the boundary between the link and the endpoint. We assign unique IP addresses to interfaces. But how do we decide the IP address of an interface when connecting the interface to the network? Can we pick a random 32-bit number and connect to any network? We assign IP addresses based on the subnet the interface belongs to. Each subnet has a range of valid IP addresses, and the interface within that subnet should have an IP address within that range. The high-order bits of the IP address define the address of the subnet, and the lower-order bits address the host within the subnet. A simple way of thinking about a subnet is that it is a collection of devices connected to each other without an intervening router. Therefore, we can think of devices connected to each interface of a router as a subnet. Based on our simple definition, a simple way of finding the subnets within a network is to detach the router interfaces and name each resulting isolated network a subnet. For example, in this figure, we only have one router. Detaching the switches connecting to this router interfaces will show that we have 3 subnets in the network. The high-order bits of each of these networks define the subnet. The number of high-order bits of the address used for subnet addressing is called subnet mask. But how many of them? The addressing scheme might be different. In this example, 24 bits are used for addressing the subnet. The rest of the address bits, which will be 8 bits, are used for host addressing within the network. So, 223.1.1.0/24 is identifying subnet X. 223.1.2.0/24 is identifying subnet Y, and 223.1.3.0/24 is identifying subnet Z. How about this network? Can you identify the number of subnets in this figure? Back to the question of how do we decide an IP address assignment, let's summarize what we learned. The high-order bits of the IP address define the subnet, and the lower-order bits address the host within the subnet. CIDR, which stands for Classless Interdomain Routing, is the Internet's IP address assignment strategy. Using CIDR, the subnet portion of address could be of any arbitrary length. That length is defined by the subnet mask. The format of the address, as we saw in the previous examples, will be A.B.C.D. A, B, C, and D are all 8-bit numbers between 0 and 255. Then /x, where x is the length of the subnet portion of the address. For example, in this IP address, 23 bits from the left, which if read as decimal numbers would be 200, 23, and 16, define the subnet part of this address. The rest, which are 9 bits, will specify the host part. The devices that are within the subnet should use the host part. You can assign them using these bits.